In today's class, we shall be looking at magnitude of vectors. Magnitude of vectors. Whenever we hear magnitude, it means size or length of a vector. Of course, we know a vector can be a line vector, it can be a surface vector, or it can be a vector in space. A line vector could be represented as this. If this is a vector A, it could be represented as this, where this is just one is having one unit vector. A surface vector can be represented as this. You have AXI plus AYJ. So you have two vectors. And a vector in space can be represented as AXI plus AYJ plus AZK. So we can find the magnitude or the size of each of the vectors. So for instance, if we have this is the y-axis and this is x-axis. This is AXI, this is AYJ. So we can find the magnitude of these two vectors. So how do we find the magnitude? Of course, we can draw a line to pass through this, and we have another here. So this is AYJ. So this forms angle 90 degrees. Of course, we can find the length of this vector. So that is what we call the magnitude of vectors. This is just for 2D vectors, two-dimensional vectors. So we can find the magnitude of this vector. And of course, we can get that using Pythagoras rule. So we have that the hypotenuse square equals the squares of the two other sides. So we can have AX. Of course, we have that the concept of dot products. So let's not go there now. So you have AX square. Our interest is in these vectors. AX, that is the vector along the x-axis, and the vector along the y-axis. So you have AX square plus AY square. So you have that A is square root of AX square plus what? AY square. Of course, this is always represented as modulus to tell us that it is always positive. The length of a vector is always positive. The magnitude of a vector is always what? Positive. Similarly, for a 3D vector, we have that A equals, for this now have modulus of A equals square root of AX square plus AY square plus AZ square. Let us solve a problem to illustrate this. So we have that a vector 15I minus 16j plus 27k is added to a vector 23j minus 40k. What is the magnitude of the resultant? So the resultant is just the addition of this and this. Of course, this is a 3D vector which we can represent as AXI plus AYJ plus AZK. In this case, the AX, the vector along the x direction is 15. Along, this is the negative y direction, minus 16. And this is z, you have it as 27. So we are going to add this and find the magnitude. How do we go about that? So we have that solution. We have, this is 15I minus 16j plus 27k we find the resultant, we add it. This is 23j minus 40k. So we don't have vector along the x, so we can have something like this. We can have something like this. So you have 0 I plus 23j minus 40k. So when we add this, we have this. So how did we do it? Have you add I to I, you add j to j, and you add k to k. So 15i plus 0i is 15i. Why did we have to put 0 here? Because if you look at the vector we're adding it to, is not having the I unit vector, so we need to add it. So this is j and this is k. So we have minus 16j plus 23j. We have this. We have plus 27k plus you have minus this. So you have minus 40k plus 27k, and that is negative 13k. So how do we find the magnitude? Assuming the resultant, we label it as A, this will be A equals this, and this corresponds to A equals AXI plus AYJ, and this is plus AZK. Of course, I say that the magnitude of a vector is always represented as modulus. So it's always positive. So we can say modulus of A equals, from the formula we got before, have AX square plus AY square plus AZ square. So once we do this, we have that AX is this 15 square, AY is 7 square, and this is, of course, this will be positive. This is 13 square. Once you do this, you have square root of 443, and this will give us 21.05. 21 point, so approximately 21. So the magnitude of this vector is 21 units. So if you have enjoyed this video, do well to subscribe to the channel and invite your friends. Of course, if this is to be force, the magnitude will be in Newton. If it is velocity, it will be in meter per second. If it is acceleration, a vector, it will be in meter per second square. So enjoy the rest of your day, and do have a wonderful weekend. Thank you.